In this video, we're going to be learning how to draw Lewis structures using the connect the dot method. With this method, you'd write each element, an atom of each element, with the correct number of valence electrons that it has. Remember to go around it 1, 2, 3, 4. Then if you have 6 valence electrons for oxygen, you would make another one there and there, let's say. And try to keep the single electrons near the in between the atoms so you can connect them. So here we see a single electron with hydrogen and a single electron with oxygen, and so these can be shared with one another, as well as these two can be shared as well. And that would be your drawing for water. If you decided to redraw that, you could draw it like this, and this actually shows the shape a little bit as well. And this is going to be H2O. O has 8 electrons, 2, 4, 6, 8. Hydrogen has 2 here, and 2 there, and that's good because hydrogen only needs to have 2 to fill its outer level, whereas oxygen needs 8. So oxygen follows the octet rule versus hydrogen, which does not. Now, if you had to do carbon dioxide, you would draw one carbon with 4 valence electrons. You would draw an oxygen with 6, and you would draw another oxygen with 6. Now what you're going to do is also try to connect single electrons. So try to connect here, try to connect here, and so far so good, except you're not done because this oxygen still has a single electron right here. This C has a single, this C has a single, and this O has a single. So what you can do is continue to connect singles like this, and even like this you can connect. Now this is a rough copy, so you're never going to write this as a final answer, but this is to help you understand that C and O double bond on the right and C and O double bond on the left. So when you're all done, you simply can draw this like that. And now carbon has 8 electrons around it, and this oxygen has 8 electrons around it, and this oxygen has 8 electrons around it. Now we're going to draw SO3, which is sulfur trioxide. This is not sulfite, the polyatomic ion, because remember that sulfite is an SO3 negative 2. So here's sulfur trioxide. It's a molecular compound. Every one of these, S and O, each have 6 valence electrons. So we're going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So what you're going to try to do is connect singles as best as you can. So let's suppose we connect this S to the O on the right and this S to O on the left. And now we're stuck. We cannot attach to this S on the top because there are no more single electrons. So what we're going to do is we're going to learn something called a coordinate covalent bond. Coordinate covalent bond. And a coordinate covalent bond is where one atom gives both electrons for the bond. So what you're going to do here is you're going to take this electron from this oxygen and move it right there next to that single one on the left. And then you're going to take this pair of electrons of the S and make that the bond with the O. So that solves the problem with the O on the top, but it does not solve the problem with these O's down here. And you cannot, with these O's, let me neaten this up a little bit over here. You cannot, with these O's at the bottom, you cannot make, let's say, some sort of triangle like this. Okay? You can't make a triangle. It's not that stable in real life, even though on paper it looks like it'll work. So what we're going to have to do is rethink this. So instead of single bonding to each of these, we're going to need to bond this S again to that O like so. And then what we're going to do is another coordinate covalent bond. So we're going to take this and move it down with that. And then we're going to take this whole pair and make it become the bond. This is obviously a big mess, so we're going to draw it really neatly, and I'll use the same colors to help you see what's going on. So here's S in the middle, and this S is going to double bond to the O on the right. So that's a double bond to this O on the right, and this O on the right still has a pair and a pair to itself. Now the O on the left is going to get a coordinate bond from the S, and this pair is now going to be down at the bottom for that O. So it has a pair, and a pair, and a pair, and this is the coordinate bond there. And the O on the top has the same situation, where it has a pair, and a pair, and a pair. So there you go. This right here has 2 coordinate bonds and a double bond. Now, even if you don't draw the final answer with coordinates, you could just draw single arrow, single lines, and it's fine. So if you just draw this, there's no problem at all with showing that as your final answer. You don't have to show the arrow at all. And this is an equally valid final structure. And lastly, this also has what we call resonance. And resonance is where you could switch the bonds around without switching the atoms. And resonance happens because this double bond could be on the right or the left or the top. So this has 3 resonance structures that you could use. And this is the connect the dot method.